Hey everybody, today we're going to be looking at proportions. We talked a little bit about proportions in our class already, and we're going to continue to work on them today. So today in your notebook we're going to be on page 68, and I'm going to pause right here so that you can write down your learning target, which is I can use proportional relationships between ratios to solve problems. And the title of today's page is going to be Using Proportions to Solve Problems. So if you want to pause the video and write that down at the top of page 68 in your notebook for today. It's important for us to understand what a proportion is. So the very first thing that we're going to do is we're going to write down the word proportion. And it's important for us to know that a proportion is a statement or two ratio comparisons that are equal in value, not necessarily in the numbers, but the values are the same. So sometimes you might be asked to identify if proportions are equal. Or if they are true. And you have to look at it like this. If I have 1 dog to 5 cats, and my friend has 4 dogs and 9 cats, are those two proportional relationships? So to test that, here's what we do. We write them as fractions, and we say my proportional or my ratio comparison is 1 to 5, 1 dogs to 5 cats. My friend's ratio comparison is 4 dogs to 9 cats. So we're looking to see if these two are proportional. So if I want to know how I jump from 1 to 4, we've talked a lot about looking for that multiplicative relationship. That's times 4. So then you ask yourself, is this a times 4 relationship? And we know that 5 times 4 does not give me 9, so that means that these are not in proportion or not proportional. Okay, so that's how you test it. Another test would be to say I ate 5 slices out of 8, and my friend ate 25 slices, he was really hungry, out of 40. So we're going to test those. So I ate 5 to every 8 slices. He ate 25 to 40. So we're looking for a comparison here, and we know that that is times 5. So if this one is truly in proportion, and the lights went off. There they are. If this one is truly in proportion, then 8 times 5 should give me 40, and that does in fact give me 40, so that means that these are in proportion, or they are proportional. But we've talked a little bit about sometimes it won't be nice and pretty like this, like it won't be 5 times 5 gives me 25. Sometimes we'll have numbers that don't work. So for those, that's called solving proportions. And we're going to use something that your elementary school teachers taught you, and that's actually cross multiplying. So if I have x over 6 equals 15 over 20, we're going to use cross multiplying. So that means we're going to say that 6 times 15 gives me 90. So whatever this is should give me 90. So x times 20 gives me 90. Well, if you don't know what that is, then lucky for you, you have the opportunity to use your calculator. So if we want to know what this is, that times 20 gives me 90, we just work backwards. So we say 90 divided by 20, and you see we get an answer of x has to be equal to 4 5/10, or 4 1/2. So I'll do a couple more just so you kind of see how this works. So let's do another example. What if for this one, it doesn't always have to be x, so let's solve for a. 2 over a equals 9 over 11.25. So this time we're going to cross multiply. We're going to do 2 times 11.25, which would be 22.5. Sorry, guys. And then 9 times a would have to equal 22.5. So if I want to work backwards, I'm going to do 22.5 divided by the 9 that I have. And that tells me that a has to be equal to 2.5. Okay, so the real key that we're trying to get to today is how can you use proportions to solve problems. So I'm going to give you a couple of examples, and I want you to see if you can kind of go with me and figure out exactly how to do this. So here's an example. Carol spends 17 hours in 2 weeks at soccer practice. So if you aren't already copying this down, please do so. How many hours would she practice in 5 weeks? Now, we've been doing lots of problems like this. I'll give you just a second to copy it down. Pause if you need to. And so we already know that the first thing we have to do is we have to figure out what we know. So we know that she practices 17 hours in 2 weeks. This is, of course, a rate. And then we want to know how many hours would that be if she had 5 weeks to practice. So when we set it up, it looks like this. Now, I want you to focus on what I'm writing. Notice I didn't just write 17 over 2. I put 17 hours and 2 weeks, because then I'm going to set up another ratio or rate comparison that matches it. I don't know how many hours it would be, so I'm going to do this, but I know that this is 5 weeks. Now, we've been doing this in the ratio table format in class, or we've been talking about modeling it, or how is it that you get to your answer. So we've talked about we could simplify this, we could figure out how much she does in 1 week, but I also want you to get in the habit of being able to use proportional relationships. So if she practices 17 hours in 2 weeks, the relationship between how much time she practices in 5 weeks should be the same value. It won't be the same numbers, but it should be the same value. So we're going to use cross multiplying to figure this out. So 17 times 5 is equal to 85. And then 2 times however many weeks, or however many hours that would be, this should be hours, should give me 85. So to solve that, I'm going to do 85 divided by 2, which would give me 42.5. So she should practice 42.5 hours. We'll do one more. It says the ratio of cars to trucks was 9 to 5. If there were 45 cars in the lot, how many trucks were there? So I'm going to give you just a second to copy this down, and then we're going to talk about how we solve this. So we're again comparing two things, cars to trucks. And that's 9 cars to every 5 trucks.